Hello everyone. We are now going to begin our lecture on chapter 1.3, which is on problem solving procedures. So what we are going to learn in this chapter is how to go about solving word problems and application based problems. We're going to learn some strategies and some step-by-step guidelines to go about solving a word problem. All right? So after we complete this chapter, we should be able to understand and use a general procedure or strategy for solving problems, especially word problems and application-based problems. Now here are some broad guidelines for problem solving. First of all, we must understand the problem. For that, we need to read the problem carefully and then understand what they are talking about. Secondly, we devise a plan to solve the problem. We have to come up with a strategy or a plan to go about solving the problem, and then we execute the plan that we came up with in step 2, and finally we check the results to make sure that our plan did solve the problem. All right, so these are some very broad guidelines given to us at this stage, but each of these steps again will have sub steps that we have to follow to find the solution to the problem, right? Now, the first step in our guideline that we just saw in the previous slide was to understand the problem. And I said that each of those broad guidelines would have sub-steps. And here we will look at the sub-steps of the first guideline that was given to us, which was to understand the problem. It says here, read the problem carefully at least twice, because in the first reading we may miss a point, especially if we are reading it fast. So it is important that we read it twice or multiple times until we completely understand what the problem is about. And then it says try to make a sketch of the problem if applicable, of course. Not all problems will require a sketch or could be solved with sketch or understood with a sketch. Label the information given, so that is as applicable. All right, and then we make a list of the given facts that are pertinent to the problem, especially for in math you need to extract the relevant data that you need to solve the problem from the wording of the question. All right, and then determine if you have sufficient information to solve the problem. All right. Now, once you have understood your problem by reading it a few times and analyzed it a little bit, we have to come up with a plan to solve the problem. So we have to lay out some strategies, and these are some ways we can do that. First of all, can you relate this problem to a previous problem that you worked before? Is it something similar to a problem that you've seen before, that you've solved previously? And then can you express the problem in terms of an algebraic equation? Does it require a formula to solve? All right. And then look for patterns or relationships in the problem. And then can you express the problem more simply? All right. Again, we will go through some examples applying each of these points that have been given to us, each of these guidelines that have been given to us. All right. So this is just talking about the strategies or the guidelines that we must follow, but there will be some examples towards the end where we are going to apply these strategies. Now we are still on the step to devise a plan to solve the problem. Another strategy we can take is, can we substitute smaller or simpler numbers to make the problem more understandable? And then will listing the information in a table help in solving the problem? And then finally, can you make an educated guess at the solution? You can work backward to determine the correct procedure. Now, not all these steps will be pertinent, will be relevant in solving a particular problem, but these are some general guidelines that have been given to us that we can use to work on a problem. All right. Now, once we have come up with a plan, we have to execute it. We have to carry out the plan. So, whatever plan we devised in step 2, we have to now use that, apply it to solve the problem in hand. And then in the final step, we check the results. Once we have executed our plan, the next step is to make sure that the solution that we came up with does solve the problem, right? So check the results, ask yourself, does the answer make sense? Is it reasonable? If the answer is not reasonable, recheck your method for solving the problem and your calculations. Go back and check your calculations, as the case may be, or go through the steps, all right, to make sure that the solution does fit the problem. Can you check the solution using the original statement? And this sometimes we will have to do in solving equations or solving something using algebraic equations. And then, is there an alternative method to arrive at the same conclusion? So these are some of the questions that you can ask yourself when solving a problem and coming up with an appropriate solution. And finally, can the results of this problem be used to solve other problems in the future? Now, here's an example problem on which we can apply some of the guidelines, some of the directives that we had learned in solving a problem. All right. So this example is on shuttle revenue. So the first point given to us, or the first step that we were told to do, was to read the problems a few times and understand what the problem is about. So we'll go about reading it first. All right. So it says here, Airport Express shuttle service provides service from San Antonio International Airport to downtown hotels approximately 10 miles away. One particular shuttle makes 16 round trips per day, carrying 5 passengers per trip. The fare each way is $18. What are the receipts from 1 day's operation for this particular shuttle? All right, so we got some idea of the problem, that it's about a shuttle service which shuttles between San Antonio Airport to hotels. It takes passengers from the airport to the hotels, and that is approximately 10 miles away. And then one particular shuttle makes 16 round trips per day, all right, so, carrying 5 passengers per trip. The fare each way is $18. What are the receipts? Receipts meaning what is the income from 1 day's operation for this particular shuttle, based on the number of trips it makes, the number of passengers it carries, and the fare for each person each way. All right. So again, let's see how we can go about applying the steps that we learned. Now, if you recall, as part of the reading or understanding the problem, we were asked to list all the information. So from the wording of the problem, we should extract the relevant information that we will use to solve the problem. All right. So one of them was distance from airport to downtown hotels. So that was given to us, distance from airport, how far the downtown hotels were approximately from the airport, and that was 10 miles. All right. What was the next piece of information? Number of trips, round trips per day. That means going back from airport to the to downtown and then downtown to hotel. So that means the round trip was 16. So each way, individually, each way together was 32 trips. All right, 16 times 2. Number of passengers per trip was 5. And then fare each way was $18. And finally, we need only the information with the asterisk. That means this part of the information, which was the distance from airport to hotels, is not relevant for us for the problem that we have to solve. All right, the important information that we will use to solve the problem, that particular problem, that how much they earned in a day, is the number of round trips, number of passengers, and the fare each way. All right. So now that we have collected the data, we can go about coming up with the solution. So the first thing they do is calculate the round trip costs. So each way was $18. Round trip means going from the airport to the hotel and then picking up passengers from the hotels, bringing them back to the airport, right? So that's 2 times 18. $18 was the fare each way. So if they are going and coming, then they have to pay $18 each time, and that's 2 times 18, which is 36. All right. And then the total receipts, or the total amount of money earned for one day, is the product, and product suggests multiplication. So it's the product of the number of round trips, all right, the number of passengers, and the cost per round trip. So we have already calculated this part, the cost per round trip, which is $36. We just have to multiply that by the number of passengers that traveled on that particular day by that shuttle, and the number of round trips that were made. All right, that was made. So here we have 16 times 5. 16 was the number of round trips, 5 was the number of passengers, and $36 was the round trip cost, for a total amount of 2,880. All right, so that's the solution. All right, so this is how we will be applying not necessarily all of the strategies that were given to us, but some of the strategies as is relevant to the particular problem in hand. Now, the next example is about calculating taxes and tips on a service. All right. So the question here says the cost of Freddy's meal before tax is $28. All right. So again, remember that the first step that we must do when presented with a problem, a word problem, is to read the problem carefully, perhaps several times, and understand what it is about and what is being asked. What is the question, or what is the solution that we are being asked to provide? All right. So again, the cost of Freddy's meal before tax is $28. The first part of the question is, if a 6.5% sales tax is added to his bill, determine the total cost of the meal including tax. All right, so it's not a very expansive problem. It's pretty straightforward. It says that Freddie probably ate outside, and his his cost, the meal cost him $28 before tax, right? So after including the tax, what would he have to pay? All right. So let's go through the process. And I'm going to write or extract some of the basic information, because remember, when we plan for a solution, we have to extract, well, not even plan, while understanding the problem, we have to try to extract the main ideas and the data provided in the problem. All right, we have to extract the data from the problem. So it says here the cost of the meal, just the whatever item Freddie ordered, the cost price of that, the cost price is $28. So that's a piece of information that we will be using at some point in the calculations. All right. And then the sales tax is 6.5%. So tax is 6.5%. So we have to know what percentage of tax is going to get added to the price of the meal. And that piece of information is also provided over here. 6.5 means 6.5%. So I'm going to write that as 6.50%. All right. So what we have to do essentially is calculate the amount of the tax. All right, 6.5% of what? 6.5% of $28 will be the amount of tax that will get charged, and that amount will need to be added to the cost price to get the total cost of the meal. So when planning for the solution, what it'll involve is we have the price of the meal as $28, right? $28. So we have to find the amount of tax, all right? The amount in dollars, how much tax will get added to the cost price. So find the amount of tax from the sales tax percentage. Sales tax percentage. All right, from the sales. So that's 6.5%. So essentially we are going to have to take our cost price and calculate what is let me write it this way. All right, we have to essentially figure out how much is 6.5% of $28. All right, that's what we are looking for. And once we calculate that, for now, I'll just say, since we haven't calculated it, I'm going to just say it's going to be X dollars. All right, and then once we know what X is, we have to go back and add it to the cost price of the meal, and that will answer the question, right? So as you will see, that is exactly what they have done when trying to solve the first part of the problem. It first goes and calculates what 6.5% is of $28, and then it'll add it to the $28, right? So look at what they are doing. Change 6.5% to a decimal, which is 0.065. Remember, I said 6.5% is to be written as 6.5%. And when you divide 6.5 by 100, all right, when you divide 6.5 by 100, the decimal is going to shift 2 places to the left. And that's how they came up with 0.065. So the sales tax equals 6.5% of the meal. So we have to calculate what 0.065 times $28 is, and that comes to $1.82. So now we know the amount in dollars of the sales tax. We can go ahead and add it to the $28, and that's what they do in the next step here. All right, so the total bill is going to be the cost of the meal plus sales tax. So cost of the meal is $28. Sales tax we just calculated was $1.82, and when we add them up together we get $29.82. Right, so the bill including sales tax is $29.82. However, when we eat out, we also have to add tips to the bill, right? So that part is probably going to be the next part of the question, right? So the next part of the question is about the tip, the amount of tip that Freddie has to leave. It says if Freddie wants to leave a 10% tip on the pre-tax cost of the meal, how much should he leave? Now, pre-tax means before tax, all right? So when determining or when deciding on the amount of tip you must leave or someone wants to leave, it has to be calculated based on the just the price of the meal excluding the sales tax. All right, remember in the previous slide when we added the sales tax to the $28, it was $29.82, something like that. However, when we calculate the amount of tip you must leave, then it is based off $28. All right, you do not need to add the sales tax amount and then calculate the tip. It's done on the price of the meal before tax. That's why pre-tax. Now the process of doing this calculation is going to be similar to what we used when calculating the sales tax. All right, but here the question asks just how much tip he must leave. It does not ask what is the total bill going to be, including sales tax and including tips and all that. It just wants us to calculate at this point how much tip, just what the amount of tip Freddie must leave. All right, so again the process is the same, 10%. So essentially we'll be calculating 10% of $28. So we'll convert the 10% to decimal and then multiply it by 28, and that will tell us that we have to pay $2.80 for the tip, and that would be the answer for this particular question. All right, so let's go to the solutions now. So here's the solution that we just discussed. It says to find 10% of any number, we multiply the number by 0.10. In other words, we divide the 10 by 100 and convert it to a decimal value, right? And then we will multiply the decimal value we found, 0.10, by the pre-tax amount, which was $28, just the price of the meal. So 10% of pre-tax cost is 0.10 times 28, which amounts to $2.80, right? Now, when we are multiplying a value by 0.10, then you just shift your decimal one place to the left. All right, that's an easy way. I mean, you can still perform or do the multiplication or use your calculator. That's fine, but this is a quick way of multiplying when you have 0.1 when you're multiplying by a decimal value, which is 0.10. So I think they also mention it here. A simple way to find 10% of any number is to move the decimal point in the number one place to the left. So 28, just move the decimal one place to the left. All right. Now there's a part C to the same problem. Again, the cost of Freddie's meal before tax is $28. If he wants to leave a 15% tip on the pre-tax cost of the meal, how much should he leave? Again, it's the same thing. It's just the percentage of the tip that changes. All right, previously we did a calculation of 10% tip. Now we'll do a calculation of 15% tip. So it's the same process, the same steps we have to perform, except that instead of calculating 10% of 28, we'll be calculating 15% of 28. All right, so let's go through the solutions. So for the solution, to find 15% of 28, just multiply 0.15 by 28. So 15% of 28 is equal to 0.15, which we obtain by converting 15% to decimal. So 15 divided by 100 gives us 0.15, and just multiply that by 28, and you'll get an amount of $4.20. So that's the amount of tip that will need to be added if Freddie wants to pay 15% tip. All right. Now you'll see over here they've done it a little bit differently. I would stick with this process. Just convert 15% to decimal 0.15 and multiply by 28. But the way they suggested here is to find 10% first. So what they've essentially done is they've broken up the 15% as 10% plus 5%. All right. So first you calculate 10%, which we already know from the previous part was $2.80. And then you calculate 5%. 5 is half of 10, right? So whatever the 10% tip was, just divide that by 2, because 5% is 1/2 of 10, and then add it. All right. So let me just show you how they've done it. But I think I would still use the first process. All right. So $2.80 was the 10% tip amount. And then for the 5%, to calculate the 5%, they took the $2.80 and divided it by 2, and then added it to the 10% tip. All right. And they came up with the same amount, $4.20. So both are correct. You get the same amount. However, I think the process on top is faster. So use whatever works for you, whichever you think is easier and simpler and faster for you. All right. Now the next example is a problem of ratio and proportion. The application is a brine solution, preparing a brine solution. But let's first read through the problem and understand what it is about and what is the solution they are looking for, right? So it says some recipes for smoking a turkey recommend pre-soaking the turkey in a brine solution. To make enough brine solution to smoke a 12-pound turkey, use 16 tablespoons of salt in 2 gallons of water. The question is, if you wish to make 3.5 gallons of a brine solution, how much salt is needed? All right, so they're talking about preparing a brine solution to soak a 12-pound turkey. And to prepare the solution, the brine solution, the proportion is use 16 tablespoons of salt to 2 gallons of water. All right, so that is the proportion. 16 is to 2. However, the question is asking not about preparing 2 gallons of water, because we already know that it will need 16 tablespoons of salt. But the question is, if we instead want to prepare 3.5 gallons of a brine solution, how much salt would be needed? And that has to be proportionate to what the amount of salt that we mix for a 2-gallon quantity. All right. So let's come up with a solution at this point. It says determine how much salt is needed to mix with 3.5 gallons of water. So first thing is to use the information we know to set up a proportion to solve for the unknown quantity. So we know that for 2 gallons, all right, for 2 gallons, we need 16 tablespoons, all right? Sorry, tablespoons. So for 1 gallon, how many tablespoons would we need? We would need 8 tablespoons. How do we know that? 16 divided by 2, right? 16 divided by 2. So you have to kind of find the proportion for 1 gallon. So we are going to have here 16 divided by 2. And now we can set up, so this is the ratio, 16 divided by 2. 16 tablespoons to 2 gallons. Therefore, for how many tablespoons for 3.5 gallons? So again, your gallons should be properly aligned, all right? You cannot have the gallon for one side, you cannot have the gallon in the denominator, and on the other side you have it in the numerator. No, it has to be uh, aligned properly. All right. So if you are talking about gallons, if you put the gallons in the denominator, all right, then it should be consistent. So 3.5 should be in the denominator just because we put the 2 in the denominator. All right. And then on top, the tablespoons will need to be aligned, but we don't know how many tablespoons to add for 3.5. That's what we want to find. So I'm going to represent that as x. All right, and that's what it is. If 16 tablespoons is needed for 2 gallons, how many tablespoons are needed for 3.5 gallons? All right, so let's look at the solution. See, they have done the setup the same way. This is the ratio, 16 tablespoons is to 2 gallons. Therefore, how many tablespoons for 3.5 gallons? So at this point, it is a matter of solving for x. All right. So let's go to the next slide where they come up with the final solution. So here we go with the final answer. We had set up the problem in ratio and proportion form. So 16 divided by 2 is equal to x divided by 3.5. So to go about solving for x here, just cross multiply, all right? So 16 times 3.5, all right, is equal to 2 times x. So essentially, to solve these kind of ratio and proportion problems, you just go cross multiply. All right, this is multiplied by, and 2 times x. Also, it's multiplication. So we have here 16 times 3.5 is equal to 2 times x. So 16 multiplied by 3.5 is 56 equals 2x, and then just divide both sides by 2. All right, divide both sides by 2 to get your answer, which is 28. So x has a value of 28. Therefore, to prepare a mixture or to prepare a brine solution of 3.5 gallons, you need 28 tablespoons of salt using the proportion that was given to us. All right, so 28 tablespoons of salt must be used to make 3.5 gallons of a brine solution. Now, the second part of the question is also a ratio and proportion problem. However, the measures are different this time. All right, so let's read through the problem. Some recipes for smoking turkey recommend pre-soaking the turkey in a brine solution. To make enough brine solution to smoke a 12-pound turkey, use 16 tablespoons of salt in 2 gallons of water. So it's the same problem that was presented earlier. However, the question is different this time. It says if you wish to make enough brine solution to soak a 20-pound turkey, how much salt is needed to make the brine solution? So this time the question says that for a 20-pound turkey, how much salt would be needed? So the ratio is between the weight of the turkey and the tablespoon of salt. That's what we will need this time. So when we set it up, we can either do it this way, 12 over 16, because that's the proportion that has been given to us as part of the question, right? And as part of the information provided in the question, they tell us that the proportion is 12-pound turkey. For a 12-pound turkey, we need to add 16 tablespoons of salt to water. Therefore, in the question it says how much salt would we need? How much salt would we need to make the brine solution for a 20-pound turkey? Again, when we create or set up the ratio and proportion, remember we have to align the units properly. So if we put the 16, the tablespoon of salts in the denominator, then we have to put the X, which is the salt required for a 20-pound turkey, also in the denominator, and the 20 up here. All right, so the turkey's weight have to be in the numerator and the tablespoon of salt would be in the denominator, or you could do 16 over 12 equals X over 20. You would get the same answer. All right, you could set up either way provided you align your units properly. All right. So let's see how they have set up the problem here. The same way as we did in the previous slide, the ratio is 12-pound to 16 tablespoons. Therefore, for 20-pound, how many tablespoons, with an equal sign in between, all right? So they have aligned the weight of the turkey in the numerator and the tablespoons of salt in the denominator, all right? So what we are going to do is we just have to replace this question mark with the X, and then we'll cross multiply and solve for X. So we'll end up with 12X equals 16 times 20, which will give us 12X equals 320 divided by 12, and we just divide, sorry, not divided by 12, 320. All right, so 12x will be equal to 320, and now we will divide both sides by 12 to solve for x. All right, so 12 and 12 divide, and we be left with 320 divided by 12, which comes to approximately 26.67 or something like that. All right, so let's go to the next slide, and that's the last slide in this lecture, to see if we got if they also got the 26.67. All right, so here we go. 12 over 16 equals 20 over x. Again, they have cross multiplied just the way we did. So 12x equals 16 times 20, so 12x equals 320. So x, you obtain x by dividing both sides by 12 for a value of 26.67. So the final answer is that about 26.67 tablespoons of salt are needed to make enough brine solution for a 20-pound turkey. All right? Okay, so these were some of the examples that pertain to this particular chapter. There are more examples in the textbook. You may want to go through them as well. All right.